All right, so we talked last time about how to graph quadratic functions, the different characteristics of those functions, and some ways to sort of predict what those graphs might look like, those parabolas. We're going to review that some today, and also talk a little bit about some of the applications for these quadratic functions. The idea behind today is to be able to find the maximum or minimum height of an object. Okay, some physics applications. There are also some business applications as far as maximizing, minimizing profits and things like that. But we're going to focus on the physics aspect today. So minimum and maximum, you have to remember that the minimum and maximum values we can find if we're talking about a quadratic function by simply finding the y-coordinate of the vertex of a parabola, whether it opens up or opens down. But the y-coordinate itself is that maximum or minimum value. Remember, the y always tells you the value of a function. Okay, it gives you the value of the function for a particular x, for a particular domain, for a particular input. Now, where does that x come from? Well, we talked about last time when we were graphing these parabolas that to find the vertex, you use this formula to find the x-coordinate. Then, of course, you plug that x-coordinate in to find the y value that goes with it. And we're going to use that idea again today. So, for example, Pat McAfee kicks a football into the air with an upward velocity of 62 feet per second. Its height h in feet after t seconds is given by the function h equals negative 16t squared plus 62t plus 2. What is the maximum height the ball reaches? Okay, well, a nice picture is always helpful for story problems. So here's Pat McAfee. He's going to kick a football. And if he kicks it, you know it's going to go up and come back down. Okay? Which is a parabola. If you look at that, it's a parabola. It's a parabola that's opening down. So for this parabola opening down, there will be a maximum value. There's going to be a highest point, which is going to be this point right here, which for a parabola happens to be the vertex. Okay? So we need to find the values of that vertex, the x and the y coordinate. Well, if you look at your function here, we see that x has been replaced by t and y has been replaced by h. So if I want to find the x value of this function, it's the same as finding the t value. But the formula stays the same. Opposite b over 2a. Okay? So you have to understand that the x-axis here is time, and the y value is height. Okay? So at some particular point in time, after Pat McAfee kicks the ball is going to reach its highest point. And that highest point will actually be the maximum height. So we got to find the t value, the time value, and we use the same formula that we did for the x when we were graphing. So opposite b here would be negative 62 over 2 times a, which is negative 16. And so t ends up being negative 62 over negative 32. And here, it's okay to go ahead and divide that out and get a decimal. Because we don't generally talk about time in terms of fractions, right? So we go ahead and divide this out, and we get a time of 1.9375. This is in seconds, which means that after 1.375 seconds after Pat McAfee kicks the ball, it reaches its highest point. Our question, though, is what is its highest point? And that's where we plug this t in. So we plug in and get negative 16 times 1.9375 squared plus 62 times 1.9375 plus 2. And we just work this out. Okay? And when we do, we get 62.0625. And remember, that's height. So the maximum height is 62.1 feet. Okay? So that's all we're doing here is really just trying to find that vertex, trying to find the t value, h value, which is x and y. All right? So try this, right? Miss Hole is playing golf and hits the ball from the tee towards the hole with a velocity of 160 feet per second. Its height, h in feet, after t seconds is given by this function. What is the ball's maximum height? Okay? Actually, I think your notes say Mrs. Coyne. Change teachers on you. That's okay. So again, the same thing. So Mrs. Coyne here is holding a golf club. There's a ball here. She hits it. It's going to go up and come back down. We're trying to find this vertex. Okay? So again, take a second and try to see if you can't come up with the t value here, the time value. And we're going to use that formula for the x value when we were graphing functions before. Try it out. Stop the video. Start it back up and see if you're right. Okay, did you get 5 for t? Okay, you should have, and that's where it comes from. So what that tells us is that 5 seconds after hitting the ball is going to reach its maximum height. Now the question is, what is that maximum height? Well, we just plug 5 in for t. Okay, and we work this out. And the ball is going to fly to a maximum height of about 418 feet. So again, story problem needs to end with a good sentence. The ball reached a maximum height of 418 feet. Okay? All right. Try the lacrosse one all on your own and stop the video, start it back up, and see if you're right. And here's what you should have gotten, except for one little thing. I didn't fix this before I showed you this, and I should have. But anyway, use the formula to find your t, and 0.625, which means that after 0.625 seconds, the ball reaches its maximum height. Now, its maximum height from where it was thrown, when you plug 0.625 into the formula, it's 13.25 feet. However, that's not the actual maximum height. There's a little bit of a twist to this one. The twist is the ball started 7 feet in the air already. So you have to add 7 feet to the maximum height of the parabola. So you're going to get 20.25 feet. Okay? A little tricky, but just remember, just kind of pay attention to whether the ball starts on the ground or at a certain height. All right? All right, the rest of this is just practice for you to graph. So I'll give you a couple of seconds. You can start the video back up and see if you're correct, but try to graph each of these functions going forward. Okay, you should have gotten this. Now I'll walk you through it real quick. In the next 3, I'll just let you work it, and I'll show you the answers. And if you're not getting it, make sure you come in during STAR after school to ask some questions, okay? But this graph is going to open up because A is positive. The vertex, we use the formula for x to find the x-coordinate of the vertex, opposite b over 2a. So positive 2 over 2 times 1/2, and you get 2. Then if you plug in 2 to the function, you're going to find out the y-coordinate of the vertex, which is going to be -3. And you can see the work down here. The axis of symmetry is that dotted line that cuts it in half. It's a vertical line, so the equation for that axis of symmetry is x equals 2. Then you got to pick 2 x's to plug in, and it needs to be on the same side of the axis of symmetry. Now I'm going to choose 0 because 0 is always easiest, and you can choose 0 as long as the axis of symmetry is not on the y-axis. It's not going through x equals 0. So I chose 0, and then I chose -2. And the reason reason why I chose negative 2 is because the denominator over here is a 2. And if I choose a multiple of 2 to plug in for x, then I will get rid of that fraction and I don't have to worry about graphing fractions. Okay? So when I plug in 0, I get negative 1. Plug in negative 2, you should get 5. Those are your 2 points, 0 comma negative 1, negative 2 comma 5. And then we mirror image on the other side because these u's are symmetrical. And that's where the graph comes from. Okay? Again, a lot of what you did for your last homework assignment. All right, try this guy, see what you come up with. And hopefully you got that. All right? Again, make sure you can find me if you're not getting this. Okay, next guy looks like this. Go ahead and give it a shot. Okay, and if you thought you messed up, you probably didn't. This is what the graph should look like. Okay, again, since that denominator for a was a 2, I chose a multiple of 2 to plug in for x. Still chose 0 because it's a little easier. Then I chose 2, and because we're getting so far away from the vertex, the y value really explodes up, and so it does fall off the grid. All right, got one more. Give it a shot, and then stop the video. Start it back up. Make sure you're doing it right. And your last one should look something like this. Okay. Again, if you're struggling with this graphing part, please come in and see me during STAR or after school. Okay. Homework's out in Canvas. Make sure you have that done by next time.